Welcome to InfoStream YouTube channel. In this video, let's discuss how to solve the checksum related problem in computer networks. So this checksum is a error detection method. That is, when a sender sends a message, that is, let us consider it as you. You are sending a message to your friend, so your friend will become the receiver. So this checksum will be in the middle and it will check whether the sender side is correctly going towards the receiver side. That is, the message sent from the sender is whether going correctly towards the receiver side or not. So this task will be done by the checksum. So how to solve the problem means, in the question there will be given the set of segments or the frames, you can call it as. So here 1, 2, 3, 4. So total 4 number of frames, or you can call them as segments, and in each segment or in each frame we will be having same number of bits. So 1, 2, 3, 4, 5, 6, 7, 8 bits here. 1, 2, 3, 4, 5, 6, 7, 8 bits. So you can call it as m number of bits, that is 8. So we got 4 number of segments or frames, 4 number of segments or frames, and 8 number of bits in every frame. Now what we must do is, we must add here, as the heading only tells, check the sum. So we must add each and every frames one by one. So first let's add first and second one. So one by one let's add them. So what is the first frame? 1, 0, 1, 1, 0, 0, 1, 1. Next another one, 1, 0, 1, 0, 1, 0, 1, 1. Now how to add means, here we are going with the binary addition. So zeros and ones are added here. So the simple trick I will be sharing here. So the trick is, when you add 0 with 1, it will be 1. You can directly denote it using 1. When it is 1 plus 0, it will be equal to 1 directly. But when it will be 1 plus 1, it will be 2. You can't represent 2 here directly, because you must represent them using zeros and ones. So here comes the concept of 2 powers. 2 power 0, 2 power 1, 2 power 2, 2 power 3. So what is 2 power 0? Any number having 0 as its power, its value will be equal to 1. 2 power 1 means 2. 2 power 2 means 4. 2 power 3 means 8. Now, what is the value we want to represent? 1 plus 1, 2. So, for 2 I will write it as 1 because I need 2 and I don't need another elements. So, I will put them as 0. Now, we know the concept that the true reading of the elements will be starting from the non-zero element. So, whatever the number of 0 may come behind, it will not be considered. The value from which the non-zero element start, from that one only we will start the reading. So, how we will read this one? 1 only. How we will read this one? 100, because you will be starting from the non-zero element. So, here the non-zero element is 1. So, 1 and 0 will be considered, and here what you will be doing is, 0 will be written in the sum and 1 will be the carry. 0 will be the sum and 1 will be the carry when you approach the condition of 1 plus 1, that is 2. So now let's see for 1 plus 1 plus 1, that is 3. So here I need 2 also, I need 1 also, because 2 plus 1 will be 3. So I will put 1 for 1 also. Now we will be starting the counting from the non-zero element, that is 1. So 1 and 1. 1 will be the sum and 1 will be the carry. So just remember this trick, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 will be 2. I will represent, 0 will come to the sum and 1 will be the carry. 1 plus 1, 3. I will represent, 1 will be the sum and another 1 will be the carry. So now let's write here. So if you see here, 1 plus 1, 2. I will represent 2. 0 will be the sum, 1 will be the carry. 0 will be the sum, 1 will be the carry. 1 plus 1 plus 1, it will be 3. So I will represent 3, 1 will be the sum, 1 will be the carry. 1 plus 0 will be 1, 1 plus 0 will be 1. 0 plus 1 will be 1, 1 plus 0 is 1, 1 plus 1 will be 2. So I will represent 2. 0 will be the sum and 1 will be the carry. 1 plus 0 plus 0, it will be 1. 1 plus 1, it will be 2. I will represent 2. 0 will be the sum and 1 will be the carry. Now the first step is over. That is, add all the segments. The second step is, if carry is equal to 1. Here, the carry is left out at the last step with 1. Add it to the LSB. What is LSB? LSB means least significant bit. So what I will be doing, I will be adding this 1 to the least significant bit. The last digit will be called as the least significant bit. So I will be adding 1 to that. Now 0 plus 1 will be 1. So all others will remain as it is, because no carry has been given to the next step. Now let's add the third segment, or you can call it as third frame for the answer which we got while adding the first two. So what is the third one? 0, 1, 0, 1, 1, 0, 1, 0. Now if you add it, 1 plus 0 will be 1. 1 plus 1 will be 2. I will represent 2. 0 will be the sum and 1 will be the carry. 1 plus 1 will be 2. 2 plus 0 will be 2 itself. So I will represent 2. 0 will be the sum, 1 will be carry. 1 plus 1 plus 1, 3. So I will represent 3. 1 will be the sum, 1 will be the carry. 1 will be sum, 1 will be carry. 1, 2, 3. So 3 means 1 will be the sum, 1 will be the carry. 1 plus 0 plus 0, it will be 1. So you can write it directly. 1 plus 1 will be 2. So 0 will be the sum, 1 will be the carry. 1 plus 0 plus 0, it will be 1. Now if you see, at the last we are not left with any carry element. So we will proceed with the next one. That is, we will be adding the fourth frame. So what is the fourth frame? 1, 1, 0, 1, 0, 1, 0, 1. So now if we add it, 1 plus 1 will be 2. So we will represent 2. 0 will be the sum and 1 will be the carry. 1 plus 0 plus 0, it will be 1. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, it will be 2. So 0 will be the sum and 1 will be the carry. 1 plus 1 will be 2. 2 plus 0 will be 2 itself. So 0, 1 carry. 1 plus 0 plus 1, it will be 2. 0 will be the sum, 1 will be the carry. 1 plus 1 plus 1, that is 3 ones means, so 1 will be the sum and 1 will be the carry. Now we got 1 as the carry. When we get 1 as the carry, we will add it to the least significant bit. So the least significant bit means this one. So if you add it, what will be the value? 0 plus 1 will be 1. No carry came, so all will remain as it is. So now this is the last remainder. So this is the remainder at the sender side. So the simple trick is, what you wrote in the sender side, just copy it in the receiver side also. So in every problem of the checksum, what you wrote in the sender side, just copy it in the receiver side. So now you just copied the same procedures which you done in the sender side towards the receiver side, and you got the same remainder at the receiver side also. So now at the last step, what you will be doing is, you got the remainder which was same as the sender side. At the receiver side only, we will add the remainder to the checksum. Remainder will be added to the checksum at the receiver side. So now what is the remainder we got? Same remainder. So I will write the remainder 1, 0, 0, 0, 1, 1, 1, 1. So this is the remainder we got. Now we must add the checksum to that. What is the checksum? Checksum is the reciprocate of the remainder. That is, 0 will become 1, 1 will become 0. So 1 will become 0 and 0 will become 1. Now let's add it. 1 plus 0, 1, 1 plus 0, 1, 1, 1, 1, 1, 1, 1. Now we got the sum after adding the remainder and the checksum. So the last and the ultimate step is complementing the answer we got. So if we complement, it will be equal to 0. So 1 if you complement, it will be equal to 0. So 8 0. So now if you see here, the 1 has been complemented into 0. So we can conclude that the message which we sent from the sender is perfectly received at the receiver side without any error detection. So we can write it accepted. So the message which has been sent from the sender without any error detected using the checksum has been received or accepted at the receiver side. So this completes the problem. So same procedure you can use for every problem related to the checksum. So more problems link I have given in the description. You can see it there. And if you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, please subscribe and support us. Thank you.